Hey guys, welcome back. So this episode is actually going to be a bit different than most of the others. Most of the others, I'm sort of just discussing things I've been working on or changes I plan on making. In this one, I've been doing some good progress. In fact, I guess I can quickly open that up and even show you like the progress I've been making on the grammar. Source Antler. Is this the wrong one? Yeah, of course. But what this episode's going to be is I'm going to take a break from the actual sort of like grammar work, and I'm going to actually just design a bash script for our program so that it can sort of operate the way that I kind of want it to. So this is going to be like a live coding sort of thing. It's basically like I need to make a video and I need to code. So I'm just going to make a video of me coding. So it's going to be slow and boring, but maybe you're interested in that. But first, before you tune out, I want to show you some of the changes I've made to my grammar. So first things first, you'll notice I've actually split it into two files, and that's because in order to use strings, I had to actually, this is kind of awkward, I had to use what are called lexer modes in Antler so that I can actually take like normal text as a part of a string. And so I had to figure out how that works, and part of the way that works is you can only use those modes in lexer grammar, so I needed to split my grammar into two files, a lexer grammar and a parser grammar. And a consequence of that is I couldn't use these symbols anymore in my parser grammar, so I had to come in here and actually define every single one of them. But otherwise, things are in like a pretty reasonable state. This is that fine? Yeah, that's fine. And then if we look at the parser grammar, you can see I have to include the tokens as specifically as token vocab from our lexer, and then I can come in here and define all of our stuff. I don't have everything yet. I still don't have structs, I don't have functions, and because I don't have either of those, I don't have any generics or trait systems or anything like that. I kind of have variable declarations figured out, almost. I also moved all of my expressions into one expression so that the tree structure won't be like a ridiculously nested thing for no reason. It will actually just be one expression is like one thing. But I have a lot of stuff already in here, and I'm pretty happy with how things are, but I'm going to change little bits of things. I'm still not sure how I'm going to implement the trait system, but I think I want traits instead of interfaces. I'm not doing OOP stuff, but traits will be good. Kind of like REST. Not entirely sure about variables yet, but they're mostly in a reasonable state. And what's the other sort of thing? I need to figure out how errors are going to be handled in my language. I'm not going to use exceptions, even though I will be transpiling to C++ this time, simply because I just want a handful of features. Like, I want namespaces for one thing, because before, every single thing I name, like C, var, whatever, right? And I had to, like, do this. This was a remnant of when I was writing in Python, which is why it's all snake case. And then I realized, oh, I could actually just do something like this. But now I'm realizing if I just make it in C++, then I can use namespaces to handle all of that, and I don't even have to worry. And I can just write the code literally and not have to care. And that technically doesn't actually have like a runtime cost, for the most part, if I'm careful about what I include. Because there's like two different ways to write C++, right? There's writing C++ sort of dogmatically in the way it's intended, and then there's using C++ simply to write C code that is slightly easier to write, you know what I mean? Taking advantage of things like templates and the type system without actually using like C++ libraries and features. And so I want to minimize the uses of C++ stuff, but I still want to utilize the useful things when I'm transpiling. For example, initializer lists are an actual type in C++, and I might take advantage of that for my language, because it's kind of useful. But today, right now, what I want to work on is the actual bash script. And so previously what I've done is I've had my sort of executable just be passed arguments. And the arguments that would be given is you give it some options. So things like, is debug enabled to print out like the tree? What's the output directory? And then a bunch of files. I'm going to do it slightly differently now because of the way that like publishing or whatever, the way that the linker that I have to make is going to work. It's going to be something like It has to automatically be able to find files based on when you import them and stuff. I'm not really too worried about implementing that right now, but what I want is to create like a basic project structure with a command. Because while it's nice to be able to do whatever you want, you know, when you're making code, it's nice to have like, you know, files anywhere, and then you can just do like GCC this C file and it works. It's also nice if you can just like run an init command and then just run a build command and everything just works, you know? Kind of like how Gradle works. Except it's not going to be nearly as large as Gradle, so hopefully it won't be as bad as Gradle. It's just going to be like a lightweight sort of thing. So what I'm envisioning is you will run like, you would come up here and run like C init, and that will create a tree structure. I guess I can sort of just make it. And what it would essentially do is it would make a directory. I guess you would do like C init like project name. So the third argument would just be the name. And if you don't provide a name, it could just be like C project something something, you know what I mean? Without overwriting existing things, I guess. So I have to be cautious about that. But it will just make a bunch of directories. And it would make like a source, like a bin, like a lib. And then there could also be a like .properties file in there so that those directories, you can specify their name so you could rewrite it. There could be like a source dir argument, like source, like just something, you know what I mean? Like some sort of thing there. And then of course it could probably also make like a git ignore file that would ignore all the bin and everything. I think my whole like include system is going to work in terms of like outside of source code. The way it's going to work is kind of like Node.js, where essentially you just have those files in like a node modules thing. In this case, it would be like a lib, I guess. I'm not entirely too sure yet how like includes are going to work at all, but that's one of my biggest issues with C and C++ in general is the using headers for everything and requiring that you fill out a header just to use code in another file. Like, that's just ridiculous to me. Like, there's some nice merit of a header file when you're writing a library so that you can just say that these things exist and not have to declare them or anything, but to use that all the time, no matter what you're doing, it's just kind of absurd. So I need to do something better than that, and I think I'm going to do sort of like a module system, kind of like Python, except it should be implicit in a way, which is why you need the project structure, so that inside of source, you don't need to have like a underscore init.py type thing. You could, theoretically, one of the things I'd like to do is you could create like your own sort of file, your C file, and you could do a bunch of imports into it from other things, and then that by itself could sort of be like a header, essentially, where they could import that and then they get everything in your library. Like, that sounds convenient to me. But it shouldn't have to be like in the form of like an init.py. Like, it doesn't need to be a specific thing, I don't think. Like, maybe it could just be called like lib, or like I'll find some way to make it work, I guess. But for now, we sort of just need to actually make the bash script. So of course, let's do our shebang followed by bin bash. And I'm not particularly skilled with bash, which is why I have the other thing on the right side here. I'm like very basic when it comes to that. So the first thing that this does is it grabs the current path, I think. It takes the directory, and then it's going to format it in a way so that there aren't like a bunch of slashes or something, I think. And the reason for that is so that this command can be like, you could place this in like user or whatever. I don't know what directories are even in user, but you could do something like that. ls/user. Yeah, and you could put in like user bin or lib or whatever. Like, you can place this bash script as the program in that location. So I'm not sure how I want all of it to work, but I think I just want to sort of work on the like taking arguments and then actually like making directories and stuff. So on this one, I had to actually utilize getops for things because I was doing legitimate like arguments where it's like dash dash or dash letters and stuff, but I think for now I don't need to worry about that. I can sort of just do it the stupid way, where we can access arguments by doing this. This is going to be the name of the file, so this is going to be the actual thing passed in. So we could just quickly check that. We can just print f %s followed by $1, then have an exit 0 at the bottom or something. Do I need semicolons in bash? I don't think they're required, no. Which is nice. And I already made this executable, I think. Okay. It didn't print anything out because I didn't say anything, but what if I said init? Then it actually prints out init without a new line, but that's fine. It's just showing it's actually consuming this, even if I take other arguments. So we need to sort of check if that thing is empty. I guess that's one thing to do. What would Gradle? I don't necessarily want to run any. If I just do Gradle, it just starts a daemon and it's upset. Did that ruin my directory at all? No, good. What it could do is if you run C by itself, it could just display the help menu, right? Like, that should be fine. Or the version or something. Maybe both. I like to sort of put the usage into, like, a separate... I don't know if you necessarily call this a function. I don't remember. But I also made, like, a print U for printing usage. And the purpose of this print statement is simply to format things in a specific manner. So I think I did 2 spaces, %-20s, followed by whatever the first thing passed into here is, or I guess second, because the first thing is always the name, tab, -5s, -n. I'm literally just going to copy this verbatim. And so in the usage, you can then do printf like normal. So something like usage C followed by, specifically in this case, it's going to be like the command. And for now, it's just going to be that. We're just going to like run a command. And we can describe what the program does. It's sort of like, for now I won't. Like, this is literally just like a very basic sort of script, right? I can sort of make it legit later. So now for these, so that we can format things correctly, we can do like a print U. And the first argument is like the command name, and the second one is like what it does. So these are the commands. I guess I can sort of actually format like this, where it's like init, and this is going to be initializes. What's it going to do? It's going to initialize like the project folder structure. And I should probably specify things that it requires, like init. How would I even write that? Well, I guess with all caps, it'd be like init project name, initializes project folder structure within, I do have to be careful of the line width. Initializes this within, and then I could say print U, give nothing, and then the second one, initializes project folder structure within folder named project name, followed by a period so that it's clear that that ends. I have caps lock on. And then down here, instead of just printing that argument, we can just print the usage. And we don't need that because it's bash. So we can just run c.bash now. And we actually see how we use it is we do C followed by a command, which I think this is sort of saying optional, but I'm not going to worry about that. But here's a list of commands. Init followed by project name. And you can see that there's some spacing here. It's basically just sort of to mimic like legit programs where if it's like make directory, it sort of just tries to look kind of like this. So that's really just the goal that I had in mind when I'm designing this. I forget which one has this, but mandatory arguments to long options are mandatory for short options too, which makes sense. So I guess I could sort of say, honestly, I could just init name, right? I don't need to say project name. I can do this. Folder name. Run this again. And then you see, because of the formatting I have here, it's always this width away, which is why I have the print U, so that it can just do this easily. Initializes project structure. I could make it a little wider, I think. Then folder named U. But it's fine, right? Initializes the project folder structure within the folder. Then folder named name. Should I specify that the folder will be newly created within a new folder? Within a new folder named name. And so you can run C init followed by a name. Now, in order to actually make that function, obviously I have to actually parse these arguments. So let's sort of do a check. Every single time I use if statements in Bash, I have to like actually remember how they work. But something like this, followed by if the first argument, I should probably use like a switch case, honestly. And I don't need it to be in a loop, but I can say something like case $1 is in, and then if this thing is, if it's init, then I can do some stuff. And at the end of this, I need the thing but backwards. Like that? Is this how this works? Oh, I needed this because I have a case inside of a case. So that's unnecessary. I think the question mark is like the else. This means, oh, what does this even mean? So if the first thing is a dash, it looks for what the rest is. $arg. Well, that's just because of how getops works. I don't, like I said, I really have no idea how this works. So if you run init, then it should like printf initializing ... followed by this. And in principle, it should also exit 0, and then that should sort of be that. And then obviously another nice thing to have would be print U help shows this usage information, period. And so then I can also parse that, where if the argument is help, then we can just say usage followed by exit 0, which is good. And then we need the I don't know what this is, and say something like unrecognized argument, $recognized command, $1. And maybe I could do like this. Unrecognized command $1 with a new line. Although I don't think this is how printf works. You're not supposed to do that. You're supposed to do this, if I remember. And then exit 1, but after I exit, or before I exit, I should also print out the usage information, since they clearly don't know how to use the program. So if I do this, nothing's happening. Valid options. Okay, so what happens if I specifically say initializing, and then I say help? Then we have command help shows this usage information. Init name initializes project structure. How about if I want to dance? So it's the question mark thing that's failing. It's because I just don't know how this really works. How do I actually do like an else? Oh, the star, right. So I think those two are just specifically because of the way the thing works or whatever, but this should capture anything else. So unrecognized command dance, and what if I do nothing? Then I should have a separate condition where if I guess I could match empty, right? In principle, I should be able to just do this before that and say must give a command followed by usage followed by exit 1. In principle, these should have two separate error codes or something. I have no idea. But there we go, must give a command. And then it prints out usage. How would something like make directory work? It would just say missing operand, try -- help for more information. Now that is one problem, is people are going to try and say /c.bash -- help. Recognize command -- help. So I might also need to do something to make that work by using the like args thing. But I can worry about that, I guess, later, because at least you can say, at least it brings up the information, right? So it technically works, it just doesn't think it works. I guess I don't need to if they provide no command, that's because they don't know how it works, right? So if you want to learn how it works, you can just enter the name and it will say you must give a command, and then it shows you the usage information. Should I put a separate new line after that? I kind of think it would look nicer that way if it's actually separated. I mean, I just don't really like how it looks either way, but it's a bit better. It's a bit more readable, at least. Okay. And, like, I have no idea if this is a good way to do this or not or anything like that, but I need something that works. So at this point, I can kind of just do the initialization, I guess. And I could put that in its own sort of, like, function to make this a bit cleaner, I guess. That's probably good. Is there function hoisting in Bash? I'm gonna assume no. So up here, I'm going to define init. And so when you're initializing, I also need an actual like argument for init, so I'll have to do a check for that. Init. And then maybe I should exit like $? To get the previous output of init, so that if it's not provided, well, it has to be given an argument, right? So I need to sort of check that here before I even call it. So like if, what's the next sort of thing? It's also going to have to be like a file name path or something, but make directory will probably complain about that for me. So init name. So the next argument would be $2. If this thing, oh, there's certain like flags to check if this is actually like a file name, I think. So let me quickly check. What would it even be under? Bash check if arg is valid, is potential valid file name, because it doesn't have to be an existing file, but it has to be something that could be a valid file name. Yeah, you need the stupid spaces around, which is weird. These are all weird. They seem to be checking if it's actually a file. I don't need it to be a file, I just need it to be sort of valid, but I think make directory can handle that. Probably. So then what I want to check is, I guess I just want to see a list of like bash if check flags or whatever they're called. There's a lot of like, yeah, like these. So it's true if that exists, true if it exists, and is a block. I don't even know what a block special file is. Okay, so -d is always for directory, E for exists, F is just if it's a file that's normal. Okay, like I don't know most of these things. That's just Linux for you, isn't it? Exists and writable, exists and executable. That makes sense. Owned by the group, symbolic link. Like, I don't even know. There's just sort of like -n is just for non-zero. I guess that's kind of fine if it's just as long as the argument exists, right? And this is non-zero. How do I negate? I'm sure I've done it here. I think it's just the normal way you would expect. You just, yeah, you shove in this before. Like, it's so weird, but it's fine. So then basically this is just saying if that doesn't exist, then we have to do some stuff. Print F must provide a name for the new project folder, period. Nah, no periods on errors, I guess. So I should printf that to the user, do an exit of some other number, some other arbitrary number, and then end that. And that should just exit there, I think. So if I then say c.bash init, line 19. Oh, because this isn't actually doing anything? Is there like a no-op? Like in Python you have a pass, is there like a just do nothing here in bash? Either way, I could probably just do like printf nothing. Let's provide a name for the new project folder. And then you see it failed, which is good. Otherwise, when it runs in it, it has to actually be given the name. If it actually is given one. So now we can do something like initializing project $1. And I might actually keep that as like just a message, even though it's like, it may as well say something, right? In it, and I can say like ctest. Initializing project ctest. And that's kind of fine. Now I need to actually do a check though to see that that thing, it could be made into a directory, you know what I mean? Like I have to check if that directory already exists. Here's the thing, right? Sometimes it's nice to make the directory beforehand, because maybe you want to set things up. But I should probably just not allow that. Just do sort of like, just make it so that it will have to make it. So I have to do a check, basically. I could just use make directory, but I should probably just say, maybe I could do the error before we even get in here. So I could basically do something like if this directory exists, and I believe it's -d for directory. If this directory already exists, then we can printf a folder named $2 already exists. And then I can exit 4 or something. I have no idea what the right way to do this is, but I just think making them distinct is probably better than making them all the same, so that at least you could somehow, like, detect which error is happening just by the number. So if we say ctest, it should be fine, but if I make directory ctest, and then I run it, a folder named ctest already exists. And in fact it does. So I'm going to go ahead and remove ctest. It's a directory. I knew that was going to happen, but okay. So now we can initialize this project. And the first step is obviously make directory $1, and I guess that's how I do it. It worked. Pretty simple. We just start by making the directory, and then we actually have to put things in there. And now, obviously, if we run it again, folder name ctest already exists. And it doesn't know that it's a C project or not, but it just knows there's some folder here, so we can't do that. Good. Next, what do we actually want in there? Well, we want a source, we want a bin, we want a lib. So we can just go ahead and make those. Now, here's another question. I might have to do that sort of argument thing. Because what happens if I run ctest with a /? Then you see it actually gets that. So what I then have to do is come up to here, and I have to actually handle that so that I have just the name. And I think this is the way I did it, where before I even pass this in, what I actually want to pass in is the result of $, I guess dir name of $, dir name ctest slash. So that's the parent directory is what that's getting. Okay, I see. I don't think I need that, because that should always be dot. So I just need the directory, and then pipe it into sed, where whatever this means is being passed in, as if I could know what that means or does, but yep. I'm sure I could understand it, but I really just choose not to, if I'm being completely honest. I'd rather not know. And so that should pass that in. And now, obviously I have to... But now if I init again, line 39, no such file or directory. Line 39, so... Is it because I'm actually, like, running? It's not because I'm running the command, is it? Like, I'm not trying to, like, execute... Oh, it is, isn't it? Because I'm trying to execute the file name. I need to do something like echo to get it into there. Yeah. But it also didn't remove the slash. So I don't remember what that was even for. Maybe that's just to get, like, the... what would it have been, right? Because this would be getting the dir name of this thing. So that would be, like, the absolute path of this. Based on where we're running. Or actually, based on how you type the command name. And then the path would be getting... I don't know what this was for, but it ends up getting the path for the program, and then you have the rest of the stuff or something. But I had to remove, like, things from the file names at some point, didn't I? Maybe that's what this was doing? Or maybe this was checking for duplicates or something. That's probably what it was doing. Again, I wrote this, but I don't fully know how it works. So we're mapping the files, something, directories, finding a thing of type file whose name is .c. So that's what that's doing. This is finding all of the .c files in a place. And then, okay. This one, though, is printing %s, which is the actual, like, file name, slash null terminated. Sort. What the heck? Relative base is dot real path. Maybe that's the command I want. Okay. So what if it's real path relative base? Maybe I still need that because these are all relative to where we currently are. $2. I don't know what that command does, but I'm about to find out. It works. That's exactly what it wanted. And I should do this before, actually. I should make a variable so that I can even print out the name, where it's like name is equal to this thing. End of line is $, yank. I'm getting better at Vim. A little bit. And then I can... Oh, what's the command to go between the quotes? Oh, that's a shame. What is that? There's one that's just like... You could just go from this quote to the previous... I don't remember. Then I can just print out the name here. And that way I can also just print out the name here. And I also should do it the right way using printf. Send name. I'll use shell check in a moment to make sure that this is even... rm init And then if I run this again, you then see the slash is also removed from this error thing. Okay, let's start by doing a shell check on c.bash. Wait, I don't have shell check installed on this? Sudo pk install shell check. I might need to use something else. No, I have it here. Okay. Shell check is a super useful utility. Yep, I did that again. That always happens. Use -z instead of this, because that apparently just means the same thing. So what was I checking? If it's... So n means not empty. -z is checking for it is empty. Okay. I'm not going to remember that, but, you know. $s followed by $1. That's the whole point of printf here. Folder name, %s already. Okay, so things are good now. Things are going pretty good. I can even do name here instead of $2. Once I know that it actually exists. But see, this should sort of all just be in the init. But then if it exits... Yeah, so I'm just going to move all this into the init. T. Let's move this over. I turned off like the auto formatting in this because I just find that it always formats in a very stupid way that I really don't like. And I could probably customize that, but I can't be bothered. So if that ever exits, what I need to do to handle that is do something like this. Instead of this, I need to do this. And you see shell check is fine with all that. So if I do c.bash init folder2 must provide a name for the new project folder. So something's going on here, probably because this is $2 instead of $1. And this is $2 instead of $1. But that's fine. Initializing project 2 already exists. ls, we made a folder 2. So now I can rm-r folder 2 and ctest. And ls, in fact tree, nice. Okay. So now we have all of our logic for the init just in one place, and we can sort of handle it like this. So the next step is making the intermediate directories. I'm not going to take... What I might end up doing is I'll have like a properties, and you can sort of like set a global like preference or something, but for now I'm just going to make a source a bin and a lib. So we make that directory. Make directory. I could do it like the stupid way, but I could also do like... Can make directory do multiple at a time? I think so, right? If I say ABC. Yes. So what that means I can do... But the issue is... I still want to do it this way, because if this one fails, then I want it to say that. Whereas if I use -p so that I can do multiple, I don't think it's going to fail. I'm not going to say anything if it fails, which that just did. So I still want to make the parent one this way. And then these can be -p though. Name slash source lib bin. So when we now init, and I'm just going to call this project, we can now tree just this, and we can actually see we have our directories that we want. A bin, lib, and a source. Which is pretty good. I think that's a reasonable structure to have. We'd also like to write a git init into just the project folder, I guess. Something that will ignore things in the binaries. Might not ignore things in the libraries. I'm not sure. I have no idea how I'm actually going to do that, but I'll have something like a node modules like package JSON thing, but something that's way less stupid if I can. All it really needs is like library name, a link, and like a version. Something like that. That's probably all it really needs to have. And then the idea is, when you want to actually include a project here, you could say like C, you could, instead of doing C init to make your project, you could say like C lib, followed by like a name of something. It could search some weird database, which that's going to be its own adventure to create. And then it could like pull things from GitHub or something, right? I guess that would be the way. I guess there's probably like a good way to do that. I could make it so all you'd have to do is like put a tag maybe. I don't know how GitHub's API works though, but hypothetically you could just like tag your repository as like a C library, and then my program can just search those tags on GitHub and see if those projects, and then find a way to automatically download them into the lib folder for you or something. Plus it also needs to search the actual like other folder for lib. So there's also going to be like a system lib folder. Kind of like for C and C++, where you have like system standard header files and stuff, but it's basically just going to be wherever the C bash lives is also where the Kotlin program is going to live, which will compile everything. Plus, I could probably put the standard sort of files up there, and then I'll figure a way to manage that. But right now, I just want some way to make a project structure here. It doesn't have to be complex, and as you see, this isn't really ridiculous. But next, we want to make... I really should do, if this fails, we should just leave here, right? And the way you check that is if $, dash equals 0 or something. I don't remember. If this equals 0, I guess I should really do this then. Do I need to do that? Exit $? That's, I hate that. I'd rather just like have the extra space than exit $? So basically, if it fails, we should really just stop and leave. And actually, it shouldn't even take the code. It should just exit like 5 or something. Let's do shell check to see if this makes sense. If it has any recommendations. Right, you can just do that, can't you? But see, that's why I like shell check, so that even if it's right, it can show you like a better way of doing things. And clearly, that's what it wanted. So if make directory name, if this will only return true if it fails, right? Because every program should return 0, which is false if it succeeds. So it should just pass by, basically. So we'll make those directories then. We can then touch name/.get ignore. Although actually I could probably just, instead of touch, I could just directly do echo something into there. And what that could be is like, this might have to be multiple lines, but I'll do it line by line basically, where it's how do you do comments and get ignores? Is it a hash? Let me just error. Ooh, that's unfortunate, but whatever. My LSP seems to think that it's a hash. I'm pretty sure it's a hash. I write get ignores all the time. You'd think I would know. Wait, what? I did run the touch command though, didn't I? That's weird. Oh, it's a hidden file. Yeah, I'm stupid. Okay. So I want to then write like generated by C init. I need new lines in this, and maybe I want printf. I don't know why. The difference between them isn't really much, but So I'll print that in, and then I'll do the next line, which will be... I should probably put 2 new lines after this, actually. And then this will be #ignore compile files. Do I even want to be a bin? Because part of the build process is making, like, not things... The whole point of bin is that's binaries, right? But part of the execution process is it's going to make intermediate things, like C files, C++ files. I could make like a build folder, and inside the build it could have a bin. But it could also have like a CPP. Or even like a build source, because it is making like its own source thing. Build is pretty familiar, honestly. People are pretty used to having like a build. And actually, I don't even have to make like the bin inside until after. So build, that's where the executable will be placed, but there'll also be folders for intermediate things if you choose to compile to that. I want a simple way to compile straight to assembly without doing anything else. I'll have a straight way to do it straight to C++ or whatever without doing anything else. And all of that can be in their own folder in build, and the main program can just be there. Okay. Let's arm-r project and then get back to writing this. I also want to add a space before here. Space, ignore compiled files, -n, and then we want to append that this time into our git ignore. I'm going to type that a lot, aren't I? So I could just say git ignore is equal to name/.git ignore, so I don't have to keep typing it. That's better. Alrighty. And then we want to ignore compiled files. So we should ignore the entire build directory. Literally the entire build directory we can ignore. And we'll also want to ignore the like properties file that we're also about to create. Which I guess I'll do that right before I make the git ignore basically, but it should by default just live in this folder and be something like c.properties, I guess. I think that's fine. And then you could set specific arguments for this project there. And I think that's a reasonable way to do this. And it's just going to be auto-generated, but it's also... should it be ignored? It probably shouldn't be ignored, because if you're going to download this project and then build, you need to have that. Okay, so I'm not even going to include that, but the git ignore should ignore built files and anything else we need in there. You can also then touch name/c.properties, and I'll just put something in there eventually. Because, does that make sense? To sort of have that. Because all you're really specifying in there is like source name is source, lib is lib. Here's where the main program lives. And that way you don't even have to run it yourself. You'll be able to just do like crun or something, right, after you compile. And it will work kind of like a makefile, but without even having to think about making one. You'll just have this command for everything, kind of like Gradle, but hopefully less stupid. But also it's probably going to be less portable, because I'm going to have to do this whole thing in bat, in like batch scripts as well for Windows and stuff, and that's going to be its own fun ride. But for now, I'm just going to worry about Linux. You know, the only operating system that actually matters. Got him. So, recognize command. I don't really even need... I don't need the quotes. So we're just making the git ignore. So now let's actually sort of run this. I kind of almost like the idea of displaying the tree structure, but not everyone has the tree command. Is there a way to check if a system has the tree command? That'd be interesting. Can you check if a command is defined? I'll worry about that in a moment. What I want to do is actually run a -c.bash. In fact, in this thing, I'm going to alias C as, so that I can say C init, which is essentially how you do it. It's just you would have an alias in some, like, better place than this, and it would run every time you're, like in your bash RC or your ZSH RC or whatever. So I could C init project 1, and then I can tree project 1. 0 directory, 0 files. Really? Does this really check if it succeeds? Do I want that? Weird. arm-r project 1. Okay, so now I want to run C init project 1 tree project 1. And then you can actually see you have a build lib, a source. I probably have to run -a to see the git ignore. And now let's check what's in the project1 dot the git ignore, and we have generated by C init ignore compiled files, which is ignoring the build directory. So in fact, if I just vim into project1, and I look at it like it's a file, it looks like fine. I could even do like 3 there is probably better realistically, so it stands out. And then I don't need the extra new line. Should I even do both sides or something? No, one is fine, I think. Just stylistic, though. This is essentially the process, though. You could just... It just makes it for you. And if I ls here, if I ls project 1 as well, we can actually see we have our build, we have everything. I do like the tree output. It'd be kind of nice if it could, like, do this. It basically is like initializing project and that shows you this, but that's also kind of maybe too much for an initialization. I mean, not really, right? Like, that's reasonable. So I would just have to check. Is there a way to check if, whoa, if a command, bash check if command exists. The hard thing is, even if tree exists, I don't know if it's the same program, you know? -v is to check. Apparently. I guess I was just on here. Or further back here. True if variable var name is set. I don't know if there's a good way to even check if, like, is it the same program? Because do I really just want to run a program on someone's system that is not guaranteed to be there? Just it happens to be alias to tree, like that. Okay. I think this is a good start, though. It's sort of like creating what I want it to end up being. Before, it was more like a GCC style compiler where you pass in like file names and it makes it, but with this, it's going to be more like you just run the dang command to like build, and it will do that. And you could specify maybe build assembly, like build C++ or C++, right? Like you could be like build C++, build CPP, either one of those, or build assembly, or build objects, or build exe. You know, like you could pass arguments like that, where you could just say C build exe, and you're building that thing, and you're building it to that stage, which would be like running GCC like -e or like -s, those weird arguments that you always have to look in the help menu for to figure out what they mean because they're so hard to remember, whereas mine would just be like, I want to build the assembly, so you just run build assembly. Like, that's it. And I could even maybe say, you know, you could write the whole word and it just checks the first letter or something. And that would be even better, right? Then you could just say, like, build A. or build C. Like, something like that is how I'll do it. Yeah, I could do something like that. And then it would actually just build it, and it would have everything that it needs. So I'm pretty happy with this so far. I'll have to make everything else work, and I'll have to figure out how I want libraries to actually be implemented and stuff, but I do think I'd like something like this, where it actually just makes the structure. I will have to fill the C properties with some sort of like source equals name/source, lib equals whatever, right? But I don't know. I'm not going to do that now. And the general idea is just that you could then change it, right? You could then come in here and be like, actually, I don't want this to be named that, so I'm just going to remove the source directory or whatever and then rename it. And then you just edit the properties to specify it should be this folder, actually. Because there's, like, even though this is such a simple way to do it, somebody's not going to want it that formatted that way, you know? And so you could have a c.properties in your project to change the project, and you can have a c.properties in your like global file so that by default it makes it using that naming convention, right? I think this is a pretty good sort of framework, so I think I'm just going to leave that here for today. This is like reasonable progress, I'd say. It's nice to take a break from the actual sort of grammar and all the other stuff I have to work on. Still have to figure out how to make a good type system. That's going to be fun. Yeah, like, I kind of know how. I sort of have done it before. It's just before, when I was doing it and I had like a symbol table, I was also transpiling at the exact same time, which was the hard part. So I think I can do it. The really hard thing, though, for me, is it would be nice if I could have compile time values that I could calculate myself in Kotlin, but I can't do it for every type. If you're using like the longest size double or the longest architecture size int, that is system dependent, whereas Kotlin, the biggest thing you have is like a long. Or I could use like an object, an actual like class to do that, but then that's going to be a lot slower, and it's like most of the time I wouldn't need that. So it's weird. One thing I could do is I could do it if I wrote this compiler in C++, then I could use the same like direct same types, but then you have to compile this on like you'd have to run my compiler as if you're compiling the code on whatever system you're trying to make. So if you're trying to build to some embedded system, you would have to run the compiler itself like on that embedded system plus the C++ compiler for that. Whereas one of the nice things about my language is theoretically it just produces C++ files that you can kind of do whatever with, you know, and you could just like edit them yourself and make them like reasonable or something. Especially with namespaces, I don't need to obfuscate the names anymore. I could just directly do one-to-one. You type a name and that's the actual name in the file, and then it becomes a lot more readable. But anyway, that's in the future. That's a lot of stuff I'll just have to think about, but hope you guys found this interesting. Just a little bit of bash scripting and a lot of confusion. Hope you enjoyed. See you in the next episode.